Hello friends, grab your coffee, grab your cookie, but maybe keep both far away from any dusty equipment, because today we are talking about combustible dust. Yes, the dust that looks harmless, behaves like fuel, and can turn an ordinary workday into a fireworks show that nobody wants to attend. My name is Michael Klepik, and for 15 years I have been designing dust collection and explosion protection systems across food processing, metalworking, chemical plants, woodworking facilities, agriculture, and more. Let me explain what combustible dust really is and how we manage it safely and in full compliance with OSHA and NFPA regulations. What combustible dust really is. Technical description. Combustible dust is any finely divided solid that can burn rapidly when dispersed in air. Technically, first, particle sizes are commonly below 500 microns. Second, the most explosive fractions are between 20 and 60 microns. Third, fine dust burns extremely fast due to high surface area. Fourth, many materials that do not burn as solids will burn as dust. Fifth, organic, metal, polymer, and chemical dusts all qualify. Combustible dust is a fuel, and an extremely reactive one. Examples of combustible dusts. Industries that produce combustible dust include organic dust grain, flour, sugar, starch, coffee, cocoa, wood, metal dust, aluminum, titanium, magnesium, zinc, chemical and polymer dust, plastic resin, dye powders, sulfur, pharmaceuticals. Additional sources feed dust, paper dust, textile dust, agricultural dust. If it can burn, it can explode as dust. Why combustible dust is so dangerous? Dust is dangerous because first, it burns faster than the same material in solid form. Second, dust clouds turn into fuel-air mixtures instantly. Third, small ignition sources can ignite large volumes. Fourth, settled layers can fuel catastrophic secondary explosions. Fifth, even a handful of dust can level an entire room when airborne. Dust hazards are silent, fast, and powerful. Conditions required for a dust explosion. A dust explosion requires all 5 elements of the dust explosion pentagon. First, fuel, meaning combustible dust. Second, oxygen in the air. Third, an ignition source. Fourth, dust dispersed as a cloud. Fifth, confinement inside a room or equipment. Removing any one of these greatly reduces the risk. Engineering controls. How I manage combustible dust. My safety first design approach includes: first, capturing dust at the source with properly designed hoods. Second, maintaining duct velocities from 4,000 to 5,000 feet per minute. Third, using FOEHN cartridge collectors for fine dust. Fourth, using BagHouse blizzard systems for heavy dust loads. Fifth, adding explosion vents, isolation valves, and anti-static filter media. Sixth, grounding and bonding the entire system. Seventh, reviewing all designs according to NFPA 652 and industry-specific standards. This creates a compliant and reliable dust control system. Common mistakes that cause dust explosions. Across industrial facilities, I repeatedly see: first, belief that food dust or organic dust is safe. Second, undersized duct velocities that allow buildup. Third, dust collectors installed with no explosion venting. Fourth, poor housekeeping that leaves dust layers everywhere. Fifth, ungrounded ducts storing static electricity. Sixth, combining different dust types in one collection system. These mistakes violate OSHA expectations and NFPA requirements. OSHA regulations. What the law requires. The Occupational Safety and Health Administration, OSHA, provides the regulatory foundation for combustible dust safety. Their guidance emphasizes: first, recognizing combustible dust hazards in your facility. Second, conducting a full dust hazard analysis. Third, identifying ignition sources and eliminating them. Fourth, implementing engineering controls such as dust collection and ventilation. Fifth, maintaining strict housekeeping to prevent dust layers. Sixth, providing training for all personnel handling dusty materials. OSHA does not give a single combustible dust standard, but enforces combustible dust hazards through multiple existing regulations, including the General Duty Clause. Following OSHA guidance keeps employees safe, prevents fines, and aligns with all NFPA codes. National Fire Protection Association Standards, the Technical Rulebook. The National Fire Protection Association, NFPA, sets the technical standards that facilities must follow. The core standards include NFPA 652, Standard on the Fundamentals of Combustible Dust, applies to all industries. Additional industry-specific standards: first, NFPA 61, Agricultural and Food Processing Dusts. Second, NFPA 484, Combustible Metal Dusts. Third, NFPA 654, Handling and Processing of Combustible Particulate Solids. Fourth, NFPA 655, Sulfur Dust and Sulfur Fires. Fifth, NFP A664, wood processing and woodworking dusts. NFPA defines how equipment must be built, how explosion protection must be installed, and how dust systems must be maintained. If you want a compliant, insurable, safe facility, you follow NFPA. Combustible dust is present in nearly every industry, from food processing to metalworking, woodworking, chemicals, plastics, agriculture, and more. But with proper engineering design, OSHA compliance, NFPA approved protections, and strong housekeeping, you can operate a safe, efficient, and fully compliant facility. I am Michael Klepik. Protect your lungs, protect your equipment, and remember, dust belongs in the collector, not in an NFPA incident report. See you in the next video.